Welcome Algebra 1 students to another Regents review video. This is the June 2015 Algebra 1 Common Core Regents exam. This is the very first one that was given a long time ago, and these are going to be the solutions to this exam. We are going to be doing part 1, which are the multiple choice, problems 1 through 12 of this examination. And welcome one and all. Before we begin here today, just keep in mind that do not take these answers and put them on a piece of paper and hand them in for homework or cheat or anything like that. If you're here to check your answers or if you were here for some guidance, you're in the right place. Just please don't use these answers to get something done to hand in to your teacher, because the Algebra 1 Regents, it's not difficult. It's a doable exam. But the only way to get better at math is to actually do the math. So please, make sure that you use this video correctly. And I'm going to say this for this series of videos, that Algebra 1 is very... this course uses the calculator a lot. So I will be using what's called the TI Inspire CX calculator. It's one powerful calculator. If you want to purchase it, you could go on my website and just follow a link to Amazon, or you can look it up on Amazon yourself, and make sure that you have some sort of calculator handy next to you. All right, without further ado, let's begin the June 2014 Algebra 1 test. Here we go. All right, number 1, when solving the equation 4 times 3x squared plus 2 minus 9 is equal to 8x squared plus 7, Emily wrote this, okay, as her first step. So she started off with this, with the problem, and she then wrote this thing down here. Which property justifies Emily's first step? Well, what's going on between the first step, the problem itself, and then the first step? What happened? Well, if you look closely, that negative 9 all of a sudden disappeared on the left-hand side. Well, what did she do to it? Well, she took the negative 9 and she moved it over to the right-hand side, because that negative 9 is added to the 7, and that's how Emily got the number 16. But what property are we doing to add the 9 on both sides? Well, that is the choice 1, the addition property of equality. Commutative property of addition, that makes no sense. You're just switching the order on the same side of the equal sign. Multiplication, we're not even multiplying, and distributive, we're not distributing anything. So it has to be choice 1, the addition property of equality. All right, number 2, officials in a town use a function C to analyze traffic patterns. C of n represents the rate of traffic through an intersection, where n is the number of observed vehicles. And it says here, what would be the most appropriate domain for the function? Okay, you see this? Where n is the number of observed vehicles, that is considered your x value. And when it says appropriate domain, domain means x. So we're looking for the answer that is appropriate to state these x values. Well, n is the number of observed vehicles. Choice 1, can you observe negative vehicles? No, you can't observe a negative car. Same thing over here, you can't observe negative cars. How about choice 3? Can you observe fractions of a car? 1/2, 1 1/2, 2 1/2? No, you can't observe fractions of a car on the road. You could observe no cars whatsoever, or you could observe 1, 2, 3, 4, so on and so forth. So the answer for this one is going to be choice 4. That is the appropriate domain for this function. All right, number 3. If a is equal to 3x squared plus 5 minus 6 and b is equal to negative 2x squared minus 6x plus 7, then a minus b equals what? Okay, so we're going to substitute in the a polynomial for a and the b polynomial for b. So I'm going to take whatever a is equal to and plug it in for a. So we get 3x squared plus 5x minus 6 minus a negative 2x squared minus 6x plus 7. Make sure that you put these in parentheses, because remember, we need to now distribute this negative 1. And what that's going to do is it's going to change all those signs in that polynomial. So we get 3x squared plus 5x minus 6 plus 2x squared plus 6x minus 7. From here, we're just going to combine like terms. So that 3x squared could combine to the 2x squared. That 5x could combine to 6x. And the negative 6 could combine to negative 7. So 3x squared plus 2x squared, that's just going to be 5x squared. 5x and 6x give you 11x. And negative 6 minus 7 is going to be negative 13. So your answer is going to be choice 2 for number 3. Now, I'm going to show you a really clever way how to check your answer on the calculator just to make sure that you're absolutely correct. Now, this is going to take a while. Well, not the calculator explanation, but each question I might show you a different way to use the calculator. So, would you agree that both of these are polynomials, okay? And there's x values here. You could actually pick a random value of x, plug it in, and see if your answer works. Let me show you how this is done. So I'm going to take the number, just because it's a calculator, it really doesn't matter. I'm going to take the number 3.2. And what I'm going to do is I'm going to store it into x. How you do that is you press Control var x. And remember, this is just for checking purposes. Now what I'm going to do is I'm actually going to type in a minus b for 3x. So I'm going to type in these. So I'm going to type in this polynomial right here. So I go back to my calculator and I type in 3x squared plus 5x minus 6. Notice how that x is bolded. That means that there's a number involved. Minus, in parentheses, negative 2x squared minus 6x plus 7. And I don't care what the number is, but you get 73.4. Fine. Now, if you go look at choice 2, type in this answer and see if you get the same result. See if you get 73.4. If you type in 5x squared plus 11x minus 13, look at that, you get 73.4. So that is the correct answer. So it's going to be choice 2. All right, moving on. Number 4, given y plus x is greater than 2 and y is less than or equal to 3x minus 2, which graph shows the solution of the given set of inequalities? Okay. Now, keep in mind, these could be graphed on the calculator with no problem. I'm going to show you that in a moment. But I want to take these and try them by hand. So I'm going to look at y plus x is greater than 2. So if I go over here and I just convert it into y equals mx plus b form, let's go ahead and figure this out. So if I take this, y plus x is greater than 2, and I move that x to the right-hand side, you get y is greater than negative x plus 2. Okay? Now let's talk about this inequality for a moment here. What is your slope? Well, the slope is where the x value is. So the number right in front of that x, that's your slope. So your slope is negative 1. Now, the y-intercept is where the graph crosses the y-axis. The y-intercept is at positive 2 right there. So your y-intercept is the point 0, 2. Now, since this is a greater than sign and there's no equal sign underneath it, this is going to be a dotted line. Okay? And since it is greater than, it is shading above. Okay? So all of these things are, so just by looking at that equation, it's so important because look, we could get rid of choices 1 and 3 because none of them show a dotted line. Choices 2 and 4 show a dotted line. Well, let's look at it. The y-intercept of 0, 2, dotted line and it's shaded above. Well, look at the dotted lines here. Choice 2 shows it shading above, and choice 4 shows it shading below it. Choice 2 is going to be the right answer. Now, just to make sure, if I take my second equation, which is y is less than or equal to 3x minus 2, we could again apply the same process. So the slope is going to be 3. That's clearly the slope of 3. The y-intercept is 0, 2. And it is a solid line, so that's good. And it is shaded below. It's shaded below. Because it is a less than or equal to sign. So the shading below occurs right over here. That's considered below. Above would be the opposite side. So your answer is clearly going to be choice 2. Now let's just say you are a little nervous, test taker, and you want to check your answer. Well, if you go to your calculator and you click on the graph, the blue graph down below on the main menu, and you click on graph, and if you actually press the delete button, it will come up as a menu of all of these inequalities. So if I were to actually, oh, my apologies. If I were to delete and type in my first one, which is y is greater than, you just click on y is greater than, and you type in negative x plus 2, and then you press the down arrow, and it graphs it for you with no problem. Now, if I were to go to this again, for the second one, I could press y. Now, to get your less than or equal sign, notice how it's not here anymore. If you press Control equals, it actually comes up as a menu of all your inequalities. So y is less than or equal to 3x minus 2. And you graph it. Now, if you notice here, the blue one, if you hover over it, it's a dotted line. And if you hover over the red, it's a solid line. So that's how we know first. And the shading is to the right. Therefore, choice 2 is going to be the right answer. And that's how you could use your graphing calculator to get these questions right with no problem. All right, number 5. Which value of x satisfies this equation? 7/3 times x plus 9/28 is equal to 20. So, now there's two different ways you could go about this. Okay? You could either distribute that 7/3, or you could first divide the 7/3, which is really just multiplying by the reciprocal. I personally like distributing. So I'm going to distribute that 7/3. Okay? So we get 7/3 x plus. Now 7/3 times 9/28. If you plug that into your calculator, 7/3 times 9/28, you get an answer of 3/4. Okay? So we get 3/4 is equal to 20. Okay, so now we continue to solve for x. You need to subtract that 3/4 on both sides. Remember, folks, that 3/4 is in fact a number. It's 0.75. So those cancel. So now we get 7/3 x is equal to, well, what is 20 minus 3/4? 20 minus 3/4, and we get 77 over 4. Okay, so 77 over 4. Now I'm going to multiply by the reciprocal, which is going to be 3/7, to get rid of that 7/3. We cancel those out, and we get x is equal to, what do we get? So we get 77 over 4 times the 3/7. And we get an answer of 33 over 4. Great, 33 over 4. But all of these answers are in terms of decimals. So we have to go back to our calculator, and I'm going to type in 33 over 4 with a decimal point after it, and that gives it to you in a decimal form. So that's 8.25, and that is going to be choice 1. All right, moving on to question number 6. The table below shows the average yearly balance in a savings account where interest is compounded annually. No money is deposited or withdrawn after the initial amount is deposited. Which type of function best models the given data? So we need to figure out, is this a constant rate of change? Well, if we go from each number to each number, look at from 380 to 562.49. You're adding by $182.49. Now, if you go from the 10th year to the 20th year, you're adding by $270.14. Immediately, just by looking at that, it's not linear. So we could get rid of choices 1 and 2. Now, it says exponential decay or growth. Well, is this increasing? Are all these numbers increasing? Yes, it is. So your answer is going to be choice 4, which is exponential growth. And that's how you do question number 6. All right. Question 7. A company that manufactures radios first pays a startup cost and then spends a certain amount of money to manufacture each radio. If the cost of manufacturing R radios is given by the function C of R is equal to 5.25R plus 1.25, then the value of 5.25 best represents what? That's a lot of reading. So C of R is, again, 5.25R plus 125. I want to talk about what each part is. This 125 that you see here, this is known as your startup cost. Okay? If you're starting a business, let's just say I want to start an Italian ice store. I need to buy the freezers. I need to buy the ice. I need to buy lights. I need to buy posters and everything else. I need to buy things to get my store operating. Then I need to pay my employees. So that's considered a startup cost, and that's considered in linear functions, that's your y-intercept. Now, the 5.25 and the r, well, the r is the number of radios. 5.25 is the cost per radio. And remember that C of r is a cost function. So cost is how much you have to pay to actually perform the business. So 5.25 best represents choice 3, the amount spent to manufacture each radio. Choice 1, the startup cost, that's not even true. That's the 125 on the right. The profit, no, again, this is a cost function. Profit is how much money you bring home. And the average number of radios manufactured, that makes absolutely no sense. All right, moving on to question 8. Which equation has the same solution as x squared minus 6x minus 12 is equal to 0? Okay, so this thing right here, this equation cannot be factored. The reason why it can't be factored by the trinomial method, as in what adds to negative 6 and multiplies to give you negative 12, is that no number satisfy those conditions. So what we need to do, and you learned this as an Algebra 1 student, you learned how to complete the square. Completing the square is just a method of, not necessarily factoring. Completing the square is a method to rearrange the numbers and force the equation to create a perfect square trinomial. So what I usually tell all my students is keep your letters on one side of the equation and numbers on the other side of the equation. So what I'm going to do first is I'm going to add the 12 on both sides. Okay, so we get x squared minus 6x is equal to 12. Pretty simple so far. Now, again, your goal is to create a perfect square trinomial. So what I'm going to do is I'm going to force my equation to have a perfect square trinomial. So I'm going to add a constant value to both the left and the right. And remember, the golden rule of algebra states, what you do to one side of the equation, you must do to the other side of the equation. So now we just added in these blank spaces. Well, how do we get what's inside these spaces? Well, you learned a formula, b divided by 2 squared, when you complete the square. You take half of the linear term. This is your linear term, folks. That's your linear term, so I take half of negative 6, and you square it. Negative 6 divided by 2 is negative 3. Negative 3 squared, that's going to give you a value of 9. So 9 goes in the boxes. Now, this is fantastic, because now what we could do is we could factor. Now, what adds to negative 6 and multiplies to give you positive 9? Well, that's just going to be x minus 3, x minus 3. Oops. X minus 3, x minus 3. And that gives you 12 plus 9 is 21. Now, another way to rewrite x minus 3 is x minus 3 squared. If you have two of the same binomial, you could write it with a square, and that's equal to 21. So we're looking for the answer of x minus 3 squared is equal to 21, and that is going to be choice 2. All right, and that's how you do that question. All right, number 9. A ball is thrown in the air from an edge of a 48-foot high cliff so that it eventually lands on the ground. The graph below shows the height y of the ball from the ground after x seconds. Interesting. For which interval is the ball's height always decreasing? Always decreasing. That means it's always going down. So where is the ball always going down? Well, it starts to go down here, and it's decreasing, 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 decreasing. So what value is this? Well, this value right here, that is a value of 2.5. So if we go over here to the right, well, what value is this? Well, that line is 5.5. So we're looking for the interval from 2.5 to 5.5. That's where this interval is always decreasing. So this is always decreasing from this point to this point. And the only one that works is going to be choice 3, 2.5 to 5.5. And that is not inclusive. We don't put equal signs underneath those signs. All right, moving on. Now it's question 9. Moving on to question 10. What are the roots of the equation x squared plus 4x minus 16 is equal to 0? Okay, so you could either do one of the following things. Now, since all of these answers are radicals, you know that it's going to be a little complex. You could either do completing the square, or you could do the quadratic formula. So it is your option. Well, it's your choice of what you want to do. So you could either do complete the square, or you could do the quadratic formula. By the way, the quadratic formula is on your reference sheet. Now, I think I'm going to do both. I'm going to do completing the square, and then I'm going to show the quadratic formula. So we have x squared plus 4x minus 16 is equal to 0. I'm going to do completing the square first. Okay? So what I'm going to do is remember that we need to add the numbers to the other side. So I'm going to add the 16 on both sides. We get x squared plus 4x plus something is equal to 16 plus something. I'm going to force a perfect square trinomial. So we get 4 over 2 squared. That's going to be 4. Plug in a 4, plug in a 4. All right? So now we can factor. What adds to 4 and multiplies to give you positive 4? That will be x plus 2 squared is equal to 20. Now, in order to solve for x, you now need to take the square root of both sides. So we get x plus 2 is equal to. Now, when you take the square root of both sides, remember that you have the plus minus the square root of 20. You have plus minus the solution. Last but not least, I'm going to subtract the 2 over, and we get x is equal to negative 2 plus minus the square root of 20. Now, if you look at your answer choices, all of these are called simplified answers, or simplest form. That radical 20 can be simplified into not a smaller radical, but could actually be represented differently. Now, radical 20 can be simplified into radical 4 and radical 5. Because 4 times 5 gives you the value of 20, and the square root of 4 can be simplified into the number 2, because the square root of 4 is 2, with a radical 5. So that's your solution, negative 2 plus minus 2 radical 5. So your answer is going to be choice 2. I am now going to show you how to do the quadratic formula. Okay, I'm going to erase all this, so if you need to go back and look at it, just rewind the video, and I'm going to now do the quadratic formula. So the quadratic formula, remember, it is on your reference sheet, so don't worry if you forgot it. So the quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Now, your a value, I always tell my students to write this down. Your a value, your b value, and your c value. Remember that your a, b, and c are numbers. This is your a value, this is your b value, and this is your c value. Your a value is 1, your b value is 4, your c value is negative 16. Let's go ahead and plug it in. So we get x is equal to negative 4 plus minus the square root of 4 squared minus 4 times a, which is 1, times c, which is negative 16, all over 2 times 1. Okay, so now what we get is we get negative 4 plus minus the square root, and we get 4 squared, which is 16. Negative 4 times negative 16 is plus 64, all over 2. So now we get x is equal to negative 4 plus minus the square root of 80 all over 2. Now the square root of 80 can be simplified into radical 16 and radical 5. The square root of 16 can be broken down into 4, with the radical 5 carrying along for the ride. So we get x is equal to negative 4 plus minus 4 rad 5 all over 2. Now, in fractions, if you have numbers that could go in evenly to each other or have the same LCD, or LC on the least common multiple, 2 could go into these numbers. 2 goes into itself once, 2 goes into 4 twice, 2 goes into negative 4 negative 2 times. So your final answer is negative 2 plus minus 2 rad 5, which is the same result as choice 2 up there. All right, and that's how you do question number 10. Moving on to number 11, almost done. What is the correlation coefficient of the linear fit of the data shown below to the nearest hundredth. Okay, correlation coefficient. That's a vocabulary word that you need to remember. And you need to remember what it is. Correlation coefficient tells us how good is the data and how nicely can I fit a line in the data. Well, there are things in mathematics that are called lines of best fit. Okay? And in this case, the line of best fit would be kind of passing through the middle of all of these points. Well, is this a good fit? Yes, because it shows a very strong negative correlation. It's going down, and I could draw a line of best fit evenly without trying to guess, like, oh, is it going this way or is it going that way? So the correlation coefficient, remember, could be from -1 is less than or equal to r, which is less than or equal to 1. This is the interval where the correlation coefficient exists. Now remember that your -1 and your +1 is a perfect line. If you have values that are greater than -1 but less than 1 inside, that either shows strong relationship, moderate relationships, or no relationship whatsoever. Now, this is a negative relationship. Okay, so we could knock out choices 1 and 2. Now, it's got to be 3 or 4. Choice 4 would show a perfect line of fit. Are these scattered points on the line? And the answer is no. So your answer has to be choice 3, -0.93. And that's how you determine the correlation coefficient of the line of best fit. Last but not least, number 12. Keith determined the zeros of the function f of x to be -6 and 5. What could be Keith's function? I don't even think that's grammatically correct. I think it should say, what could Keith's function be? I don't know. Okay, so the zeros are -6 and 5. Now remember that these are your x-intercepts. Okay? Those are your x-intercepts. That's where the graph crosses the x-axis. So it could look something like this. If I were to draw just a quick sketch of what this might look like, it could look something like this. -6. Okay, so your graph could look like this. So that's x equals -6, and this is x is equal to 5. Now, we need to figure out what the factors are. Now, you should have learned this in your Algebra 1 class. If the roots are x is equal to -6 and x is equal to 5, your factors, or the factors, are x plus 6 and x minus 5. And here's the reason. If you take the factors and you set them equal to 0, they give you these roots up here. So your factors are always the opposite values of what the 0 is. So your answer for this one is going to be choice 3, x minus 5 and x plus 6, because if you set this whole function equal to 0 and you t-bar it, you get 5 and -6, and that is going to be your answer. All right, that is the conclusion of this video. I hope that it helped. Please hit that subscribe button down below and make sure that you visit www.nysmathregionsprep.com for much more math content, and I hope to see you soon.